My name's Keith. I'm the development manager at Sun Branding Solutions for my sins. Formerly, I was the technical architect. I've been there for about 6 years now, and it's been quite an interesting journey. When I started at SBS, our technology stack had everything from VB6 to classic ASP, web forms, MVC, Python, Apple script, and all that's still there for our old clients. And we were a very traditional software development house. We had virtual machines running on a host in the cupboard. We did development in 6-month-long death marches based on specifications that the clients didn't care about by the time we actually delivered them, and all that stuff. We've kind of turned that around. I'm still in the process of turning that around, but we're a long way down the road. We are now pretty much agile, small a and big A. We're doing 2 weekly dev cycles, we're doing 2 weekly releases, albeit we're still doing some of the releases from my machine, and it crashes every time my machine has a problem, but gloss over that. We're hosting stuff in the cloud, we're running on as bleeding edge as we can possibly get without severing a main artery. I've got to be careful what I say here, because Jim, who sat over there, used to contract with us, so he actually knows what some of it's like in reality. So.
And we still want Sam to come and work for us.
Yeah. It's all good. Kev gave me the brief for doing this talk, and it was basically talk about 4 cool technologies that might be of use if you are looking to move into the cloud. And it's fairly challenging to break that down into 4 technologies. Done my best. So we'll see how interesting it is. Is it turned on?
See, this is the difference in systems problem and development problem.
Yeah. Win. So the standard joke about the cloud is that it's just hosting on other people's computers, which it is. And we've been able to do that for donkey's years, all the way back to hosting with people like One-on-One and Rackspace. But it's also not that. Many years ago, when I first signed up a previous employee to Rackspace, we wanted a server with a certain amount of RAM and a certain amount of hard disk. Rackspace said, great. And they sent us a massive, great PDF document with a network diagram with a server in it and a firewall and a lot of documentation about the SLA. And the whole thing took about a month. And by contrast, we then tried One-on-One, and then it crashed after about the first month. And that was how it was. That was the alternative then to on-prem or co-location. The notion of cloud, I first became aware of it when we outgrew that server at Rackspace. We had more space than the hard drive could take. We had to get a bigger server. And I had to sit up all night while the content FTP'd from one server to another and got through 3 series of Blackadder whilst doing it. And at the time, I was sat there about 3 a.m. on the 5th cup of coffee thinking there's got to be a better way of doing it than this. And about the same time, Amazon S3 was starting to become a presence. And that was a revelation. I can just get storage, and I can get as much storage as I need, and I pay for what I use. And that was the real difference. It's not just that you're hosting somewhere else, because frankly we all do that. We all co-locate, or I'd imagine very few of us actually run servers in the cupboard. Admittedly, we still do, a few. It's a fairly big cupboard with fire suppression. It is still a cupboard in the corner of the room. At my first company, it literally was a cupboard in the corner of the room with a B&Q air conditioner, and our junior IT tech's job every day was to empty the bucket that it collected the water into. They're still going. It's still running. Cloud it's not just a technical shift, it's a mindset shift away from the way we used to do things. I've tried to define it. It is a very boring and a very technical definition because I'm a developer. Computing at scale using virtualized commodity hardware as a service. Try saying that fast. The key words there are scale and commodity and service. Cloud is all about cloud came about because Amazon had a lot of spare computing capacity, which interestingly was the same situation that my father was in the 80s when he ran a bureau service back in the mainframe days when you sold off your spare mainframe capability. And we've kind of come back to that way of thinking. But it's also tied in, or is tying in, with some other concepts that have been kicking around for a while this century. Concept of agile. Cloud makes agile attractive, and in turn agile makes cloud a necessity. Scale. There is only so far you can scale with on-prem kit without massively overspeccing stuff or continually making your financial director hate you. Automation. If you are computing at scale, there is a limit to how many machines a sysadmin can manage. With some sysadmins, it's one. People get Word documents wrong. We've all worked on systems where doing a release meant following a 50-page Word document and missing the middle step, or the fact that the middle step hadn't printed, or whatever. You need automation. If you are running 1,000 servers, you do not have 1,000 admins running each individual server. And DevOps. Automation is scripting. Scripting is development. That all ties in. Continuous life cycle. If you can automate things and you are an agile, big A and little a company, you can use continuous life cycle to get your changes into production faster. So I'm going to come on to the first of the technologies that I'm going to be talking about, which is Azure Web Applications, host all the things. This is a screenshot of one of our production web apps. I hope I've managed to crop out all the connection strings. If there are, just cover your eyes and avert it. We'll blur those out in the video. Azure Web Apps. We have been on Azure long enough now that the platform as a service platform that we started on has since been deprecated, and we've actually moved off it. So we started off on something called cloud services, which is basically a group of virtual machines running in a logical set. We have now moved off that, in part because to develop on that you had to run a horrible thing called the Azure Fabric emulator on your machine, which took about 10 minutes to spin up every time you hit F5, which is a pain in the ass. Azure Web Applications are Microsoft's current recommendation for hosting anything web. You can host .NET, PHP, Java, Python. You can run Node applications on them. And it's essentially IaaS as a service rather than IaaS, which is very easy to get confused. You can set these up online. And again, this comes back to the whole notion of DevOps. To create a new web application, I can log on to the portal. Don't need a credit card because we've got an enterprise agreement. Kev will just shout at me later about the extra expense. And set up a new application. And actually, in terms of expense, again, not wanting to sound like a salesperson for Microsoft, but it's not actually that bad. The way it works is that you set up a hosting plan, which is basically a set of VMs. And once you've got that, you can run as many websites on those as you need. It's basically like having a big server, and then you create as many virtual applications as you want to. So cost-wise, it's fairly effective. It does all the things that Kev was talking about. The hosting plan will auto-scale. We currently run on a premium hosting plan, and I think at rest there are 2 instances, scaling up to a maximum of 10. Last month, Kev asked me why we were spending so much on Azure Web Application hosting. It turns out that Kev had done an experiment where he had set the maximum number of VMs to 10 and the minimum number of VMs to 10.
It turns out it scales really well between those limits.
But it was very fast throughout that period. There are some cool things about web applications. They are very cheap to get started on. If you're doing hobby projects, you can actually run, I think, a free version still. It will stop after about 2 days because bandwidth will just trigger your limits. But if you've got a few quid to spend on it, you can do it for maybe a tenner, £20 a month, which for a hobby project is feasible. You can actually run quite a lot on that for not very much. The whole thing is configurable on the web. It's also configurable by automation, which I'll get onto later. There's some nice things about configuration. It's actually one of the things that's a very small thing, but it's something I love about the Azure Web App Platform. You actually can't see it, but down here on this side, you can configure the app settings of your application. So you can actually put in connection strings and application config values that will override whatever is actually sitting in web config or whatever other technology you're using. And that was actually a revelation for us, because managing web config files and the transforms required to get them from dev to production was kind of a big deal. We actually, for a while, had a specialized application that ran on your machine and took a copy of a web config template and transformed it with the right connection strings. And everyone, at some point, everyone checked in their configuration into source control. So suddenly, the production server will be trying to connect to Geet's PC over in India and failed for some reason. This allows you to keep a lot of that information completely out of source control and completely away from people who shouldn't have access to it. It's a small feature, but it's been absolutely fantastic. And you get nice stuff. You get graphs showing you how busy the server is, how many errors you're getting, and all that good stuff. Key concepts around that. MS Deploy. You can deploy to web applications using Web Deploy or MS Deploy, whatever you like to call it. Documentation is horrendous, but it is very powerful and very effective. Interestingly, you can also deploy to it by pushing to a Git repository. Each web app is its own Git repo. If you push to that repository, you will publish to the website, which is kind of cool. You can also connect to it via FTP and do a more traditional deployment. Deployment slots. We have a question.
Sorry, just a quick session about continuous integration and sort of regression testing.
Yeah.
Maybe it's its own Git repo. How do you check that the build succeeds before?
In that instance, you don't, basically. If you do use the Git auto-deployment feature, it will take a Git repository. It will run a build of that using something called Kudu. Basically, you have to have a solution with one website project in it. It will then take that website, if it builds successfully, and deploy it. You don't get any more control than that. If you want to do more, we use TeamCity for continuous deployment and integration. You need to go to something like that for full control.
Just to be clear, the application itself is a Git repo. It doesn't mean it's necessarily the same Git repo that you use for your source control. So we're using Git as a source control mechanism, and we're using that for our repo. You can then have a CI server, TeamCity, Jenkins, whatever, pick up that and push it to another repo, and that is effectively your publish.
What you tend to find with Azure is that there are at least 3 ways to do the same thing, and which way you choose tends to be a matter of preference. Other cool stuff, deployment slots. You can set up a staging, for example, slot that is basically a shadow of your app. You can do cool stuff around auto swap. So you can publish to a staging instance. That will then warm up. So it will actually hit that website, load the first page, and by the time AspNet has actually compiled the first page and got running, it will then swap it around. So you don't get the sudden slowdown as you deploy an application and AspNet suddenly realizes it's got to actually recache templates and so on and so forth. But you can also use that to actually host multiple, you can have your tests and your staging and your dev instances on the same application. And then deployment is just a matter of clicking swap, and you promote the instance up the chain. We don't do it like that, but it's an option. Kudu is a service that sits on, that actually runs the application. You don't get RDP with a web app, but what you do get is a Kudu console that lets you browse what's on the physical disk. It lets you look at thread dumps. It lets you change what's on the disk, so you can do a quick sort of typo fix, for example, if you didn't want to do a full deployment. It lets you see what processes are running and even kill processes, so you get a sort of task manager in there as well. Web jobs are a hugely useful and hugely painful feature at times. A web job is basically just a console application that you run inside your website. It's an exe, it's deployed inside app data, and and they can either be scheduled or they can be continuous. If you're doing anything like queue processing or image processing, it's great. It'll run in the background continually and pick up messages from a queue or a blob store or anything like that. The pain comes when you do deployments, because web jobs really don't like stopping. They are very good at running, and they will run no matter what, even if you're trying to deploy a new version. And we have had a few pain points where we've had 2 versions of the job running on the same queue, and led to some fun. We've since figured out to get around that. There's a config setting you can put that will just kill them stone dead, and you have to set that first and then do the deployment. These are the sort of lessons you learn, and it's all stuff that's in the documentation, like Kev said. But you've got to know where to look, and you've got to actually read it. And half the time, you hit the pain point before you read it. But again, it's a far better experience than running a Windows service. So that leads on to cloud automation. I realise this isn't really a single technology, but I couldn't decide whether to talk about PowerShell or the management APIs, so I've lumped them all together in one. For those of you who listen to .NET Rocks, this is Richard Campbell's favourite saying: servers are not pets, they are cattle. You don't keep a server. We've all worked on applications where you can't touch the production server because we've tried building a new one and it just doesn't work. That shouldn't be how it is. Servers are disposable. You spin one up, you shut it down, you create another one. They are just something you can script, build, run on, and get rid of when you don't need it anymore. I considered putting a picture of an abattoir in there, but I thought we might have some vegetarians in, so it's probably a no-no.
By the time you put the picture up.
Yeah, it's true. And at root, automation is all about APIs. There are several ways you can automate Azure. I realise we're both talking a lot about Azure, but all of this holds true for AWS and any other cloud provider worth its salt. If a cloud provider doesn't provide you with automation and APIs, probably don't use them. It all comes down to the API. So PowerShell, VB if you want to use VB, and C# can all be used to script Azure, but they all come down at root to the Azure REST-based API. If you're in the .NET ecosystem, you've got NuGet packages. You can install a storage management package that will let you spin up new storage containers and new storage, new queues and things like that. And there are management packages for compute, for VMs, for cloud services, and pretty much everything that Azure do. Or there are PowerShell equivalents. So it's a matter of personal preference or practicality is which one you choose. And it pretty much gives you Intellisense for Azure. So that's a quick example taken from the web. But that is an example of taking one of the NuGet packages to manage Azure, and in this particular instance, creating a new storage account for it. And that's massively powerful. If you were running a Saas application, then it's a fairly common model that you have each customer separated into their own database and website and so on and so forth. Using automation, you can do all of that programmatically. You can create a SQL database, you can create storage accounts, you could create the website, and it's not just Azure. DN Simple provide DNS. They provide an API. So registering DNS and subdomains can also be done automatically. You can script all of that. There's no human intervention required. That gets you, and again, it depends on your business, but it means that in some cases you don't have to make the compromises that some of us sometimes make when writing SaaS applications. You can give the same benefits of an application per customer with a fully automated sign-up process that will massively lower your costs. We didn't choose to go down this route. We went down a more traditional shared infrastructure, shared data model route. But this is the sort of example of things that you can do. If you can trim out a couple of days up to a couple of weeks, say, for someone to create new servers and new databases for a new client, and you can just do that via a web-based sign-up, and someone puts their credit card in and suddenly they've got their own DNS. That's massive. You've made a massive cost saving. Your IT people can go off and do something more productive, and it will probably screw up less often. NoSQL. NoSQL is an interesting one for us. We are still broadly a traditional SQL house. Most of our skills are in SQL, and I think that probably holds true for the majority of the .NET world. There's a number of NoSQL stores around there. They all do broadly similar things, although some like Hadoop are more column-based stores. Document DB, Mongo, RavenDB, and CouchDB, for example. The key difference really is around scaling. Obviously, SQL will scale vertically. You just put more RAM in the server and you build a bigger and bigger server. NoSQL stores traditionally will scale horizontally. So you will partition your data by a certain key, and then that data will be distributed over as many servers as you like. The important thing, and the thing that we found when we've dipped a toe in NoSQL, is that you really can't think of it like SQL. Whichever technology you use, whether it's Mongo or Couch or Raven or Azure Document DB, doesn't really matter. You just have to change your mindset. You are no longer dealing with something you can query. There is a tendency, I think, when using SQL to assume that because things are in a database and are in a schema, you can query them however you want. And obviously with SQL, that's not true either. You have to define indexes, you have to think about how your queries will work. With NoSQL, you can't afford not to do that. Because if you do not design your data correctly up front, you're screwed. NoSQL is most powerful when you have huge amounts of data, because it performs on huge amounts of data. The downside to that is that it has huge amounts of data. Same as the other key benefit is that it has no schema. The downside is that it has no schema. In fact, I don't think that's necessarily true. It does, all the data has schema. The trouble is, the schema is now up to you to develop. And it's actually even more important to define that schema up front. Give you an example of that. We have a sort of hybrid solution. We store documents as JSON in a SQL database, which are serialized from .NET objects. The developer recently added a Boolean property to one of the objects. The entire site crashed because that wasn't there, and it's a non-nullable property. So how do you get it? And that stuff is relatively easy to deal with, but it's stuff that you don't have to deal with SQL. And suddenly now you do have to deal with it. And the other big difference with NoSQL in terms of architecture is that you aren't dealing with one source of the truth anymore. SQL is very much about normalizing data, about having a single record, about not repeating values. NoSQL kind of says, sod it. Give you a copy of that, give you a copy of that, give you a copy of that, because this is historical data, it doesn't change. Again, that's fine if you design your application around it. If you suddenly realize after 3 trillion rows that you've made a mistake in your schema, you're a bit screwed. You've got to go back and figure out how to cope with old versions of the schema. What it does give you, like in terms of architecture, because you don't have a fixed schema to work with, you can actually afford to have multiple versions of your application storing different schema models. And so long as you think up front about how you're doing that and you tag your data appropriately, you can actually run concurrent versions of your application against the same data store. But you have to think up front about how you're going to migrate data from old versions to new. And that's pretty much what I've just said there. I just mentioned that we store JSON blobs inside SQL. Do not do this. Seriously, do not do this. It is a bad idea. It's a very bad idea. Bad things will happen. Octopus Deploy do this. They probably have better developers than us. It's kind of the worst of both worlds. You end up with developers trying to substring things to find data. You also get concurrency nightmares because suddenly this whole blob of data is in one cell of one row and 2 people try and update it at the same time, and all you can do is fail one and retry. again, do not do this.
Sorry, so you're by using MongoDB or one of the others for your general database storage, that's surely contributing to the massive size of your data though.
We don't at the moment use that.
The majority of our data is not database data. It's the external blobs that sit around that relational data. So what we store in a relational, and as Keith said, we store JSON blobs as well as a kind of non-relational store, but within the relational store, because that seemed like a good idea at the time. Learning curves and brilliant things. But the majority, what we store in those is really asset IDs and pointers and so on. Similar to if you think about kind of SQL's original storage of var binary maxes and so on, it would store blobs elsewhere on disk, and what you were really storing in the relational store was a key that would point to a separate location on disk. We've sort of abstracted away from that, so we store the assets on a RESTful storage service. We put an asset, we post an asset to that, we get an asset based on a key. The relational data really only stores the pointers to those. So our relational data is much smaller, with tens, hundreds of gigs rather than terabytes or petabytes.
Would it not be cheaper to do that in table storage or something like that? Why leak that in SQL?
The short answer to would it be cheaper is yes. The answer to why we didn't do it with table storage originally was because we tried table storage and just didn't scale. Didn't scale at all. But that's because we were really early in the days of that storage, and we didn't really know. If we'd known the rate at which we would grow in terms of usage, and we'd known the rate at which Microsoft would improve the storage services, I think we'd have been really comfortable going with it at the outset, knowing that our usage was much smaller than they could cater for at the time, and that as our usage grew, their capacity would grow faster. But we couldn't be sure it would grow faster, and we did know that our projected end point was beyond their capacities at the time. And SQL does scale pretty well, and people have been doing it for decades. And also, as Keith said, our skill set is very SQL-y. We're a dev house that's got people who've been doing dev for 20, 30 years. All of the people in this room that are devs will have at some point written some SQL. I would hazard a guess that almost none of the people in this room have done any production work on a Document DB type store or a table storage type store. So we had a lot of skills around SQL that were easy to port. And that was kind of the second nail in the coffin of table storage at the time.
But going back to your point about does that not give you more storage? Yes, it does. But at the same time, storage and database storage is very cheap on Azure. In terms of writing an application, think about how Facebook works. They have billions and billions of posts going in all the time. If you go onto Facebook, you see a news feed which has a few hundred or a few thousand articles, which is unique to you. That news feed is pre-computed for you, and it is massively duplicated. They have a background process that accumulates all of the keys, the relevant posts that you might be interested in, and dumps them into a table. So from their point of view, it's basically, I don't know the internals, but it's basically, get me this data for this person. Same with us. We have a system that enables users to do tasks that are assigned to them of various types, and there are millions and millions of these at any one time. In our legacy platform, we attempted to get that by using a relatively normalized schema and trying to do a query across the whole thing, and it crashed and burned because you had dozens and dozens of tables to join across. We do that in our current application. We are moving to do that in the current application by basically just having a big Document DB table of tasks. And we have a process that dumps data into there. And we partition it by user. So finding the user's tasks is fantastically quick. It's duplication, and it means that we need to make sure that if changes happen to the core data, we need to roll those out. But we can do that on queues.
So is that not, it's basically using it for data warehousing?
Not even that, really. We use SQL for data warehousing. It's operational, running data. It's designing data stores that the application runs on, and data stores that are designed to support the application, rather than building an application around a normalized data store. And that's really been the key mindset shift we've had to try and get around. Azure Document DB is a service that Azure provides, which is what, as Kev said, something that we are that we're moving on to. The nice thing about Document DB, and again, there are plenty of other choices out there, but the nice thing about it is that you can write queries in a SQL-like language that under the covers gets translated to a JSON data type. For us, with a lot of SQL Server and SQL skills in general, that helps the learning curve. You still need to think about all the sort of NoSQL caveats and indexing and all that, but at least it's a bit easier and a bit more familiar to get on board with. And the last technology I want to talk about now is .NET Core, which is, I think, absolutely fantastic. I've been working on it since the first betas came out. I've had the pain of upgrading with every single beta, and I will have the pain of upgrading from RC1 to RC2 because they've changed the entire command line infrastructure again. With all that said, I still think it is probably the best move Microsoft have made for a long time, and it has been a shot in the arm to the .NET community, which at times has perhaps been at risk of becoming a bit stale. Generally speaking, the web world, the Node.js's and the PHPs and the Pythons and all that, and the Rubies and all that, have moved somewhat faster than .NET. They're all off using NPM and Grunt and Bower and Gulp. .NET has been a bit slow to catch up on that. And in part, that's been because .NET is Windows. And if you want to run .NET, you need Visual Studio and you need Windows. And with the cloud world we're moving into, price of virtual servers is key. And with that in mind, Linux becomes much more attractive. And that, I think, is probably the driver behind Microsoft making the move to make .NET Core run cross-platform. .NET Core is, in theory, cross-platform. There are a lot of things that you can't do cross-platform because a lot of .NET, it turns out, is written on the Win32 APIs, and you just can't do those in Linux. And they're having great fun because Linux doesn't have a cryptography store, but Windows does, and all this lovely stuff. But it's cross-platform. You can run a basic website, you can connect to SQL databases, and you can do actually quite a bit with cross-platform .NET Core. We've got about 90% of our application running cross-platform now. The bits that we haven't got are image processing, ImageMagick. ImageMagick, despite being a C++ and Linux API, its .NET wrappers are only available on Windows, which is frustrating. And there's a few other bits and bobs. Random stuff like Excel APIs and libraries. Hand in hand with that, you've got Nano Server, which is basically Windows Server that fits in a few meg rather than a few gig. I forget the exact number. To run on that, you need something that's lightweight because that won't have a lot of the things that a full Windows Server installation does have. And again, to do that, the Microsoft team have had to make .NET Core modular. So rather than having a giant monolithic framework, you now pick the pieces you want. You say, I want threading and cryptography, and you end up with 100 NuGet packages, but it's all good. HTTP platform handler. IIS doesn't really have a lot to do with .NET Core. It just spins up a console application that runs your app. And that same console application can run from the console. You don't need IIS installed. You don't need IIS Express installed. You can just, at the moment, you type DNX Web, and in the next version it'll be .NET Web. And the whole thing springs to life in a way that the Node.js world has been doing for a long time now. And again, we are gradually catching up in the .NET space. The future is probably platform agnostic. SQL Server will run on Linux soon, which is something I never thought would happen. Windows 10 will have a bash shell run by Ubuntu. Choice of OS will become less and less important. In that world, the tools that we choose to use will have to be tools that can be ported from platform to platform, which at the moment basically leaves Java and .NET. Again, Java in theory. And .NET Core is awesome. No more CS proj files, which are a merge nightmare. MVC and Web API merged. Yay. More global ASX. Yay. run from command line, auto recompile on changes. I'll stop 2 seconds on that one. From a productivity point of view, if you were back in 2005 and writing a web forms app, you might change a page or change a bit of code on the page. You'd have to stop debugging, make the change, start debugging again. That's up from 5-10 seconds up to maybe a minute or so, depending on your application, that's just gone out of your life to make one change. And that leads to a development process that is very much make changes, run it, it's not quite right. Sorry, it's good enough. I can't be asked to change that because that's just going to take too long. Not always, but that's the sort of feeling that it engenders. If you look at the stuff, I used to be a PHP developer, and in PHP you make a change, you hit F5, and there it is. In .NET Core, you've got that again. You're in Visual Studio, you make a change to one of your core libraries, you hit F5 on the browser, and the change is there straight away. Because of ROSL and because of how fast you can compile C# these days. And you can do that on the server as well. You can actually deploy, this is where Kevin winces a bit, you can deploy a .NET Core application as source code to Azure. And if you make a change and hit F5, it will have changed. I quite like this feature, and Kev hates it with a passion. I like the fact that I can see what code is running. I've had too many times where I have tried to figure out which version that this DLL is. Is it that branch, this branch, or is it something that someone's decompiled and recompiled and dumped on there and not changed the version number?
Wasn't that something that was available on web forms, though? When you had to deploy the CS file, otherwise it just didn't work?
You could only do that if you ran a website project, if I remember rightly. You couldn't do that with a full website project, a full web application project, sorry. You had to put the code in the app code as well, if I remember rightly. It's horrible. There are pluses and minuses to it. If you've got an undisciplined dev team who will just go in there and make changes and not commit them, it's a bad thing. However, if you're trying to debug a tricky issue in production and you just desperately need to put a log statement in there to see what's happening, it's a godsend. And you can compile the whole lot without Visual Studio, which is a massive plus when you're in a continuous integration environment. It's just command line. If you look at how .NET is built now, the .NET Core libraries that are up on GitHub, they compile using a batch file. You type build.command and the whole thing builds. It bootstraps itself, it downloads NuGet, it downloads all the dependencies. It's fantastic. Our continuous integration process for our .NET Core app is just run build.command. Brilliant. Love it. And that's me.
That was much quicker.
Yeah. That's what the mama said. Has anyone got any questions? Yeah.
I noticed you didn't cover security.
Yeah.
Obviously, stuff being out there in the public in the cloud is potentially less secure. How do you go about making sure that you've created a web app, it's a web API 2 object, so you're serving data and getting requests. How do you make sure that's secure?
It depends which bit really. The web API bit obviously is the same whether you're on-prem or off-prem. Azure is certified up to the eyeballs for security. Kev will know that better than I do because he likes that sort of stuff, and it's his job. But for us, we have as Kev said, a relatively small IT team who are not all security professionals. We were running in a co-location facility, and our response time for that was 20 minutes because that was how long it took our sysadmin to drive from his house to the colo facility. If we had to repair servers, our downtime was 40 minutes because that was how long it took to take the server out, drive back to the facility. We are far more secure running Azure than we ever were when we ran things ourselves.
Can I just slightly extend that then?
Yeah.
Do you find that you're doing more in terms of making sure that web app is secure than what you were when they were being hosted locally?
From an app point of view,
No.
From an app point of view, so we get regularly pen tested. We sell into companies who expect check accredited pen tests and all the rest of that stuff, and that hasn't really changed at all. From being on-prem to co-load to cloud, fundamentally, as Keith said, cloud is just hosting it on someone else's computer. So we used to host it in a colo center, In Kit, yes, we owned, but it was in a colo centre, so it was really kind of someone else's computer on someone else's power with someone else's aircon. Before that, as Keith said, it was in the cupboard, which was our computer in our cupboard, but it was still fundamentally a web app with external facing, ports open to the general public, whether they be ATN 443 or a smorgasbord of other services that you expose or don't. We get the regular pen tests, and some of those pen tests have been good news, and some of those pen tests have been slightly less good news. My favourite thing, I think, was not long after I joined, we had a pen test who discovered that we had a publicly facing, self-documenting SOAP service, so you could go to adminservice.wisdle, and it would give you a question mark WSDL, and it would give you a self-documenting piece of code that showed you how to create a user, make it an admin, reset his password.
I don't think you get that with Web API, though, do you?
You do.
Web API gives you a WSDL.
You can.
Self-documenting.
Swagger. Swagger will do
there
that
is
for you.
Swagger, and you can self-document. But
Right.
the fundamental part about that is if you write stupid apps, it doesn't really matter whether you put them in the cloud or you put them in a cupboard. It's still fundamentally a stupid app. The underlying infrastructure part of that, in terms of which bits changed by moving it from a colo center to the cloud, we used, so the colo center that Keith's referring to is a company called SunGuard. They host out in Elland. They've got data centers all around the country. We used to host at SunGuard. We didn't really care if anyone was on our machines because it was our machines running in a piece of rack space that we rented from them. Microsoft have got thousands of security people around the world working to protect their infrastructure and our kit and all of their app, the fabric that sits underneath it, from hackers and script kiddies and all the rest of that, evil, nasty people and North Koreans. There is a whole security infrastructure that we gain by moving to the cloud, which we didn't have before. Microsoft are opening UK data centres this year. There's going to be a northern and a southern one. We're not quite sure where they're going to be yet, but we're expecting Manchester-esque, and we're expecting London, Reading, Cambridge, something like that. The MOD are their signature partner. The MOD are putting classified up to secret level data in Azure, in the UK, in data centres hosted and operated by Microsoft. We host packaging assets. Yes, there's IP around it, and yes, if you're a counterfeiter, it's nice to know that somebody's going to release a new product in 3 years, because you can counterfeit it and copy it. But fundamentally, the MOD is going to put stuff in there that's classified up to secret, and they've gone through a whole process of accrediting and auditing, and the gentleman to my left at the moment works for the NHS, and the NHS have got data in Azure already. And
not just Home Office and we're talking HSBC Bank,
Yeah.
all have the data on the cloud.
CESG,
It just justifies the security level that they have.
CESG have looked at it, and there's the CESG core G-Cloud competencies and so on and so forth. And fundamentally, for me, it boils down to the fact that if you write stupid stuff and you leave backdoors left, right, and centre in your app, it doesn't really matter where you put it, because frankly, you can host it anywhere and you've still got the same stupid backdoors in your app. If you don't put those backdoors in, the cloud has got to be at least as secure as a data centre that's run by the vast majority of companies in the UK. Maybe if you're BT, then potentially you've got a big enough security team to look after that infrastructure yourself to the same competency level. But yeah, so for us it's a security plus, not a negative by any stretch.
Yeah.
Part of security is business continuity planning. How quickly could you get your infrastructure out of Azure if, I don't know, they turn around and say, rather than half a penny in Nix, can be 40 million?
Again, the answer there kind of depends on the application you write. We try to write our applications such that any Azure dependencies sit behind interfaces so that we can swap them out. We haven't got Azure equivalents, but we could if we needed to. We've never tried, is the honest answer.
We would struggle, probably the more honest answer, maybe one before the camera points this way. We would struggle for some of it, is the short and honest answer. We've made a commitment to writing an application that runs on Azure's platform as a service application. As Keith said, it's abstracted behind interfaces for the most part. We've made a conscious effort to architect the software so that we could swap it, but could we just move it to Amazon? No, not in a month of Sundays. But it's not that different than making a decision to stick with Windows versus Linux as an OS platform. You're committing to a platform, and if that platform goes away, you're basically knackered. We looked at a lot of cloud providers. There are certainly cheaper providers out there than AWS, Google, and Microsoft. Rackspace have got their own private cloud and so on. All of those, and again, if there's anybody from Rackspace in the room, I apologise, but Rackspace's commitment to cloud, I have no idea. They could turn around tomorrow and say, do you know what, actually, we were quite happy with fanatically supporting physical kit in a data centre, and we're going back to that. And if we were pinned to the Rackspace cloud, we'd probably be just as knackered right now. Azure, Microsoft have spent a lot of money. The vast majority of Microsoft services run in Azure. So there is a possibility that they'll turn around and make it commercially unappealing for us, at which point we would do the maths like we would any other investment and say, is it sufficiently unappealing that we're prepared to pay the money to move away, or do we just bend over and take it a little bit? And you know, that's the nature of IT and platform and provision and comms, and it's the nature of the world we run in. Yes, we've made reasonable efforts to abstract away from it, so that we're as good a position as we can be to move away without building ourselves such a technical challenge that we're incapable of delivering anything because we're so busy being paranoid about what happens if.
Are there any customers that have sort of walked away from doing business with you because you're hosted on the cloud?
Yeah, and again, point that way. Yes, there is a large supermarket in the discount space which is German in origin and it's not called Lidl, who have a blanket policy of we don't deal with cloud. And that's been an uphill battle for us because we do deal with cloud, we deal extensively with cloud, and we very much want them to. We want their business, we want to continue servicing them, and we want to do that in the cloud, and they at the moment are relatively unwilling to entertain that conversation. However, they're an SAP customer. SAP S/4HANA is a cloud-based multi-tenant platform which runs in a single multi-tenant instance whether you like it or not, and I don't care how big you are, SAP is bigger, pretty much. They might not be the biggest company in the world, they're smaller in terms of turnover than Walmart, but there's no one to move to if you're a Walmart or a not little. So it is becoming easier. The bigger companies, the SAPs for example, where previously everybody said, well, we've got our own data centers and they're in-house and we're sticking with it, it's becoming harder for that stance to maintain its position. If we go back 18 months, a big green supermarket not a million miles from here was very anti-cloud, very anti-cloud. I really probably can't repeat some of the conversations for protecting the innocent. But their cloud providers list was ridiculous, frankly. But we were really early going into them as an application vendor saying we want to move to the cloud, and we were the first one really to have that conversation with them seriously, and it was a bit of an odd conversation for them, and they didn't really know how to do it, and we were only one vendor, and it wasn't really worth investing a lot of time and effort. That's changed over the last 12 months, really. And the conversation, I have quite a few conversations at board level with some of our clients, and the question I usually ask them is, do you use Flickr or Facebook or anything? And they'll say, yeah, of course we do. So what do you put on there? And just personal stuff. Right, so you'll trust pictures of your kids to the cloud, but not pictures of your lasagna. And that mindset shift is happening. People are starting to realise that actually the cloud is, again, to use the overused cliche, it's just a computer somewhere. And actually, if you architect for security and you encrypt at rest and you do all of the things that are good practice, whether it's in the cloud or not, being in the cloud is a benefit, not a drawback. But yeah, it's still a real battle.
In your continuous deployment, how do you deploy the database changes and the SQL changes that require, especially index changes that require rebuilding stats?
Currently, it's an SSDT package that we just publish using PowerShell script. We are looking to change that so that we do fewer deployments, but it will probably still be a SSDT package that we deploy. We make fairly few database schema changes. Occasionally we might add a column or change a constraint, but it's fairly rare. So we're in the fortunate position at the moment that it's a problem we don't have to deal with too much. On our legacy platform, where everything was a stored procedure and we had about 7,000 procedures, it was a nightmare. And we had a custom program for doing it that crashed half the time. SSDT has been far, far better. It's the least sucky of all the options, basically. There is no good way of doing database change management.
Just going back to your sort of anti-cloud cloud sort of premise, I've been in that position trying to push, let's go to the cloud to save money and all that jazz. Where I was, it was sort of, we have to be in Europe and we have to guarantee we're in Europe. Oh, I know it's in Dublin, it's in Amsterdam. Is it? And how do you sort of manage that? Well, it is. So perhaps a legal question, but
no. Well, it's a question that we get asked as well. And again, part of the rationale behind picking Microsoft was that they are very good and very proactive around their Trust Center stuff. There is a tremendous amount of documentation, more than you're ever going to want to read. I have a lady that works for me that does all of our ISO 27001 stuff, and she enjoys ISO 27001 enough to want to do it for a job. She still finds the Microsoft volume of stuff overwhelming and boring. They're ISO 27018 certified, which is the cloud hosting provider thing. They're 27001 certified. They've got Safe Harbor accreditation when Safe Harbor accreditation existed. Safe Harbor, as it comes back in, is probably going to change. They're CESG check certified. They're G-Cloud-based suppliers and so on. And actually, for most of our, we're not supplying GCHQ, the NSA, and MI5. Obviously, if we were, I couldn't tell you, but we're not. They don't do packaging. If they did, we'd be right up there. For the majority of our customers, they want to see due diligence, they want to see some degree of legal credibility, and they want to see us back off their liability. And we've been able to do that relatively easily because we're convinced enough that Microsoft's protections around that are sufficient for us to put our name on it, on the line, and we've gone to our customers with, we're promising you this, we're committing to this. We're not saying the cloud provider will keep their your stuff in Europe and they promise it, and if not, you can take it up with them. We're saying, we have arranged hosting and provision which is in Europe, it stays in Europe, we're committing to you that it will stay in Europe, and if not, you can sue us out of existence. Actually, our parent company has big pockets, so they're pretty reassured by the fact that they probably would get paid rather than bankrupt us. But they've been confident enough, because we're confident enough to go in with those assurances, that actually it's not been that big a sticker. They all ask the question, especially when there's PII and payment information and all of that kind of stuff. Everyone wants to know they're not breaking the DPA.
Yeah, that's the sort of questions that was
the general data protection regulations that are coming in and so on are changing a lot of that for a lot of people. But again, Microsoft, and they're not alone in it, but we just find them easy to work with because it fits fairly well with our methodology national. The changes that they're bringing in legislatively, Microsoft have anticipated, they've worked with, they've been involved with in some instances. They've got Microsoft Council are involved in legislative working parties and standards bodies. So it's been a relatively easy pitch on the basis that here is a wheelbarrow loads worth of documentation. If you want to go through it, fine, but you can clearly see that we've done our homework. And it's the same, my approach to that is kind of the same as things like RFIs and RFPs and tenders. Nobody reads whatever you write. You can fill in an RFP and you could put in there, I love bread and jam. No one would ever notice. They just look to see if you've answered the question. They don't care what you've answered it with. They just want a compelling story. I realise it's probably a slightly trite oversimplification because people do occasionally read one. But for the most part, the fact that you've done your homework, the fact that you are ISO 27001 compliant, the fact that you've audited your suppliers and they are ISO 27001 compliant, and that you've ensured that their accreditations are up to date, and that you've got pen tested, and that you've got independent verification, and so on. It's as good as anything else.
Data in transit in the cloud and moving infrastructure. How does it affect you?
We keep most of our stuff. So these are your questions. We keep most of our stuff in Europe. We keep almost all of our stuff, with the exception of Walmart's stuff, in Europe. Microsoft, again, there's assurances that on their backhaul everything is encrypted. The data that we store is encrypted at rest, so they can replicate it, but they're replicating encrypted data, not clear text.
Between your actual office and your virtual private cloud, and I presume you fragmented your virtual private clouds, you've got lots of virtual private clouds running so on. How do you do things like set up VPNs and sort of?
So we don't currently VPN into Microsoft's data centers. They do offer a service called ExpressRoute, which is effectively a private MPLS link with encryption end-to-end and all the rest of it. We don't currently use it, we just go over the public internet. Everything we do is SSL secured, and again, for the level of sensitivity of our data, SSL is enough. We do host some PII, but not very much. We don't hold payment detail because the companies that we work with are paying us millions of quid a year on a few invoices, not tiny credit card transactions. So some of our life is a little bit easier around that. SSL is plenty for what we're transiting. But yeah, we've looked at MPLS and ExpressRoute for speed and performance reasons, but the security on that would be a bonus for us rather than necessity.
Slightly related to the question asked earlier about the business opportunities of customers that are walking away from you as a provider because you're cloud-based, do you think that there'll come a point where there'll be enough opportunity for you to consider like a two-step approach where you have some customers serviced in the cloud and others on premise?
So we already do, and again, if there's any of my customers in the room, pop your ears for a second. We already do, in the sense that Microsoft had a thing called Azure Stack. We've worked with Microsoft under NDA for quite a long time with Azure Stack. It's now in public beta and it will be in general availability very shortly. And Azure Stack is the ability to run on Server 2012 R2 or later and Azure cloud environment. So it basically emulates Azure on-prem. So we do have an answer for customers that really absolutely categorically would, and I guess it goes back to your question as to how fast we can move off as well. But for customers who absolutely categorically will not cloud host, we are able to spin up either on our premises or on theirs, Server 2012 infrastructure, a couple of load balanced HA clusters, Azure Stack on top of that, and it will emulate storage, it will emulate compute, it will emulate everything else, and the app would run without changes on an on-prem infrastructure. However, that does provide us with a significant challenge in terms of supporting it, because it's now on-prem and it's meant to be a cloud app, and so we expect that we can get to it and manage it, and it wouldn't be on the cloud anymore, it would be on their premises potentially.
So they offer you the infrastructure, but Microsoft basically say, the minute you take it on-prem, it's yours to worry about.
Yeah, the Azure Stack is quite literally a layer of fabric that sits on your infrastructure and pretends to be a cloud infrastructure.
The Azure portal you saw up there earlier, you basically get that running on your machines.
Right.
With all the capabilities of it, but it's yours to manage and it's behind the customer's firewall.
Bets are off at that point, it's yours to
Well, they support it. Obviously for us, it's the same challenge as if we're installing an application in the customer's data center. We're a Saas cloud-hosted provider. We deploy updates to our servers. Deploying updates to another customer's servers that could be running different OSs and have different systems is a challenge we as yet haven't had. To do that, there's obviously a significant commercial implication. We have to get more people on to do that and support it. And generally speaking, if you put that to clients, they go, oh, yeah, I suppose we could do cloud.
And that's basically what it boils down to, is that most of them, when you give them the compelling you give them an alternative that is real.
Yeah.
It's not vaporware that we're waving in front of them saying you could maybe do this with a bit of work. But if we deployed, again, if we deployed into the NHS Information Centre's infrastructure, there is a better than fair chance that they're going to have a problem with us having unrestricted access to their infrastructure to go in and make changes as we see fit. It's just not something you get with customer infrastructure. So all bets are off in the sense that Microsoft are no longer responsible for the upkeep of the hardware, they're no longer responsible for the upkeep of the disk or the network or anything else, because it's not their infrastructure anymore, it's the client. But normally when we have that conversation, the answer is, oh, actually, yeah, that does sound like suddenly we're responsible for running the hardware. Maybe if there was some way that we could kind of get a provider that would run all that hardware for us and provide all the uptime guarantees. And it tends to get back around the table. We haven't yet had anybody walk away. We've just had clients say, we're not going to take it yet.
The likelihood is they would ask you to host it for them, just on your prem rather than.
Yeah. And then we'd just charge them through eyeballs. Because we would, but we'd be incurring a lot of extra costs. We have to go and buy all that kit that we wanted to get rid of. We have to support it and do all those things that we didn't want to do. But would we do it? Yes. If your pockets are deep enough, I would do almost anything.